Since the normalization will be into three normal forms and we will achieve one normal form in every step, it makes sense that we will have three normalization steps. The first step is to go to the first normal form. In the first normal form, our main focus is to get rid of any multi-valued attributes, which are also called repeating groups. We need to remove all of those so there is a single value, and this single value can be null at the insertion of each row and column of the table. We will also need to identify the primary key at this step. Now the second normal form is going to be the first normal form, but then we need to add the following. We need to get any partial dependencies out of what we have in the first normal form. And we define the partial functional dependencies as when the non-key attributes are identified by the whole primary key. Now the third normal form is when any transitive dependencies are removed from the second normal form. So we will go gradually between forms. We will do the first normal form and then we will remove the partial dependencies. Then this is going to be in the second normal form, and by removing transitive dependencies, this will be in the third normal forms. And now we will talk about each one of those dependencies in more details when we talk about it. We will dive into an example, but let's first look at some dependencies and let's try to see what's going on and to understand what sort of dependency do we have in that case. Now, first of all, let's define what's a candidate key. It's a unique identifier, which is one of the candidates that will eventually become the primary key of our table. So if we look at this table that we have right here, our candidate key can be employee ID, which is eventually going to be the primary key in this case because we don't see any other key that is more suitable than this. Now, a full dependency is present when we have each of the non-key field functionally depend on the candidate key. So what is our candidate key? In this case, we said it's employee ID. The non-key fields are name, department name, and salary. So we can safely say that the name and the department name and the salary will change based on the employee ID. Whenever I see another employee ID pop up in the records, it will have a different name, different department name possibly, and different salary possibly. So these three attributes will totally rely on the employee ID. For each employee ID, we have specific values for these attributes, and hence we have a full dependency on that candidate key. What about partial dependency? So let's look at this example and try to see what's going on. Now the candidate key in this case is going to be the employee ID and the course title, because we have the date completed. So this is a different table. We have some information about courses with some information about employees in the same table. Is this a good table? No, but we're trying to make it a good table. In order for us to make it a good table, we need to understand the dependencies that are going on this table. Now we have those candidate key parts, and then the rest of the table, name, department name, salary, date, completed, are all the non-key fields. So if we look closely, we have some full dependency here and we have some partial dependency in this case. What do we mean by partial dependency? We mean by partial dependency when some non-key fields depend on a part of our candidate key. Now our candidate key in this case is a composite primary key which consists of two parts, employee ID and the course title. And if we look closely, we can see those three depend on employee ID. So we are relying on a part of the primary key. So we have A partial dependency in this case. What about date completed? If we look at date completed, it relies or depends on the whole key. So this is a full dependency like the example that we have seen in the previous slide. Now let's look at a table with multi-valued attributes and see how it's going to look like. Now this is an example of a table with multi-valued attributes, and if we look closely, this only has two records, 1 and 2. Now we have multi-valued attributes for the products, which is making all of those rows with empty data, and then we have those multi-valued attributes, or what we call repeating groups in this case. Now, is this in any normal form as we discussed? The answer is no. It's not even in the first normal form, because in the first normal form we need to identify the candidate key or the primary key, which is done in this case. We have order ID and product ID, but then we need to get rid of all multi-valued attributes. But we still have multi-valued attributes in this specific example. How can we move it to the first normal form then? We will discuss this in the next video.